You mean a for loop like what I did with empty semicolons? You wouldn't. Like you would use while true. It just a for loop. Some older programmers, I want to say, are more used to doing it like that, like doing an infinite loop like that. There's not really a great reason to do it that way. I actually don't know. I think the compiler will optimize it out to be exactly the same as a while true. So really, it's just a semantic difference. Whatever you feel like doing at the time. Do you feel like typing out the word while, or do you feel like typing out the word for with a couple of semicolons in there? Oftentimes, though, you don't see completely empty for loop like that. You'll see only one or two of the three pieces implemented. So you'll still want to do something every loop, but you don't want to leave it completely empty. And that's why for loop you can pick which part you want to do. Maybe you just want to do the initialization part and leave the other two empty, or just the test part and leave the other two empty, or 2 out of 3, right? You can pick and choose which ones you want. It's pretty rare that you'll see like an empty for loop like that. But I do want to say it's supported, but you would just use a while true. It makes more sense. It also is a little bit easier to read. Okay. Where were we? This is me reviewing. I was going to have you guys do this, but I don't think we need to do that. Okay. I want to talk a little bit about objects in C++. So games are complicated things, and what we've been doing up to this point really has been all about simple manipulation of variables that live within C++. I'm talking about things like we're manipulating numbers, like integers. We're using floating point variables, things with decimal places. We're using strings, and we're using like booleans too. A lot of times, though, in a game, like the reason why programming works is because when you're making a game, you're dealing with integers and bools and floats and all that stuff, but you're dealing with them at a level that is not, that it's kind of like when you, let's say you're responsible for like starting a car, right? All you have to know to start a car is put the key in and turn the key. If you're driving a manual, then you push the clutch in and you turn the key. But like your interface with a car is literally just stick a key in and turn it. But think about all the things that actually have to go in to actually get your car started. Think about how the car manufacturers have essentially simplified that down to a single key turn. You guys know, like in the old days, you had to like crank, like you had to stick like a crank in the front, you had to like turn it, to, like prime it, and then there was like ignition switch. You had like I think in some of the older Volvos, you had to like prime the fuel pumps and like turn on. There's these bulbs in the old like Mercedes. They don't have spark plugs. They have like plugs. They're like hot plugs that like basically stick into the combustion chamber. There's a lot of these like switches you have to like turn on before you start the car, right?
Like the Model K's or even before those?
No. This is like even like the 1970 Volvos. Like there's some cars that you just can't like turn a car. You just can't turn a key in and turn it, right? Like, but for the most part, the act of starting a car is pretty simple. Like you turn the key. Even the act of like driving the car is pretty simple. You push the gas and you steer it. But like, what actually happens when you push the gas, right? What actually happens when you push down the accelerator pedal? A lot of things are happening behind the scenes. The air-fuel mixture is being controlled by a computer. The throttle is actually controlling how much you actually want to, how fast you want to go. But all that stuff is happening kind of behind the scenes. You're not manually controlling the air-fuel mixture and like manually turning on the spark plugs as the car is moving, right? All that stuff is automatic. That same idea is kind of how games are made, right? Like you want to be making a game by making things easy to use. For instance, in Overwatch, if I want a hero to take damage in the game, I actually have to go through, there's a lot of steps that are involved to taking damage. You might not think it, but if you actually try to break down all the pieces of a character taking a hit, think about the stats that have to be tracked. Think about like all the effects that have to play when you take damage, not just the value of health. Think about testing whether you should die or not. Think about like spawning the effects associated with, like not just on your body, but on your player HUD, like the red effects that show up, and the sounds that have to play when you take damage. All those things need to happen consistently every time you take damage, right? So to that effect, it's kind of the same idea. Every time you turn a key, you want it to behave the same way. So when you're running a game, oftentimes you're dealing with these things that make it simple for you to interface with what you want the game to do. So oftentimes in the case of like Overwatch, for instance, we have Tracer here. she is not a number. She's not an integer. She's not a float. She's not a bool. She's not a string, right? She's represented in the game by a variable. Actually, there's a hero that you can pull. There's something that represents her in the game. However, what she actually is a collection of other variables, which themselves are also collections of other variables. So these collections of variables define what Tracer is. So what I want to talk about are these things in C++ called objects. So Tracer I'm going to treat as an object in C++. She's not an object. I'm not objectifying her. I'm saying that, like, as in the game, she's represented by something called an object. So an object in C++ consists of two primary things. This is kind of how you describe anything. One is the properties that describe her. So things that describe what she is. Like, for instance, how fast she moves, and how much HP she has, or how tall she is, or even if she's alive or dead. These are things that describe her state. These basically are what we're going to call her member variables. These are variables that describe what she is at the time that she is in the game. Okay. Then we have a concept of what she can do. Okay? These are things that Tracer herself can do. These are not the things that define Tracer. These are things like Tracer has an ability to blink, and has the ability to shoot her guns, has the ability to recall or jump. These are things that she's capable of doing. These are what we're going to call member functions. I want to describe this in effect of a couple of examples. So I'm going to use a car, and I want to describe a car in both of those ways, via its member variables and via its member functions. The member variables here are going to describe the car and what it is, while the member functions I want to describe it in the context of the things that the car can do. So in the context of a car, the things that a car is, the member variables are how many doors does a car have? Right? Is it 2 or 4? How many tires does a car have? Right? Yeah, it depends. But this is a variable. It's an integer that describes how many things a car has. Right? What are other things? Like, what year is the car built in? What model and make and color are the car? Those are describing the car. These would be the member variables. Then we have the things that the car can do. It can move forward. It can turn to the right and left. It can start. It can turn off. So a car is described in like two kind of separate pieces. So let's use a game example here. We have this like spacecraft. It's a very simple example in a game. Like think of like asteroids or like Space Invaders. It has properties that define what it is and what it has. For instance, it has an integer variable that describes how much energy it has. It also has the ability to fire weapons within it. This would be the member variables of this object, the spacecraft, and that would be the fire weapons would be the member functions. So let me describe this a little bit more in terms of a game too. So if we were to take a game like Pokemon, let's just take a specific Pokemon here. Let's just use Pikachu, because every single Pokemon game or anime has to have Pikachu in it, right? Primary. Can anyone give me some properties that describe Pikachu or Pokemon in general? Like, what things describe those? What's that? Male or female? Gender?
Attack type.
So color, attack type. How about things like HP, SP, attack, defense? Right?
How cuddly it is.
Is that a property you can define with a number? From 0 to 100, I guess?
I guess.
Other things like whether it's dead or alive. What level it is. The name, status. I think you guys get the idea, right? These are properties that describe this Pokemon object, this Pikachu object. What are some things that a Pokemon can do?
Attack.
It can attack. It can run away, right? What are some other? It can die. These are things that you can tell it to do, essentially. Like imagine these are like commands you can give to Pikachu, right? He's vulnerable. You can tell Pokemon do suicide, right? I don't think you can, right? Self-destruct. Well, only certain Pokemon. Pikachu can't. You can evolve. So you guys see where the distinction lies here between things that you can call and properties that describe that Pokemon? So we actually have already been using these without knowing about it. We actually have been using an object that has this concept of variables and functions on it. The functions meaning things that it can do for us, things that you can tell it to do. And that type is called a string. We've used strings already. And understand that strings are actually an object. It's actually a collection of properties. A string is actually just an array of characters, right? But it has a bunch of stuff surrounding it that helps it do more than just that. So let's talk about this. I'm going to demonstrate a little bit about what strings can and can't do. Now remember, a string is just like we create a variable called name, which is literally just the name of the string. So there are some things you can do. This name is actually an object, which means it has properties, it has member variables and member functions. And here's how I can prove it. When you do name and I do a dot, can you guys see this? Can you guys see this like drop-down box that shows up?
Yeah.
So this represents the set of all the member functions and properties that I can access. So every single one of these little cubes represents a member function that I can call, which means I can tell this string to go do something for me, and oftentimes it'll go do something and then tell me the result of what it did. One of the most common things you do with a string is, can anyone tell me how many characters this thing has? Can anyone count that for me?
Painfully.
Yeah? Well, I don't even need to do that. I can actually do a cout and tell this string to give me how long it is. So I can say name.size, and .size here, this is a member function that I call. You can see that's a member function because I'm calling a name with parentheses on it. No, this has nothing to do with pointers. Don't worry about it. You didn't say that word. It's fine. We're not going to get to that yet. We will get to that soon-ish. We'll get to that for anyone who's taking the next class. We'll get to pointers. Okay. For now, I have this little guy. Look at this. Look at this thing that I'm doing on this name. Name is the name of my variable. This is the variable name. I gotta call it something else. I'll call it word 1. So it'll be a little bit easier to understand. So word 1 is actually an object. So how do I get to the member functions and the member variables? Use this operator, the dot operator. This allows you to get at those member functions. It allows you to do things on that object. So when you put a dot after something that is an object, you can now all of a sudden access all the things inside that object. Watch what happens when I do the dot. I get this drop-down box of all the things that are member functions and member variables inside this string. Which means I can call any of these and it will go do things for me. For instance, in this case, I just want to call size. If it's a member function, if you call it, you have to have parentheses on it. Like so. And what this does is, size is a member function. I'm telling it to give me back how long this string is. And it's going to return that back to me as an integer that I can use. Okay. So I know that it printed out 21. It went and it figured out how long those characters are. Okay.
You always have to rewrite the parentheses.
So most of the time, in this case, you're going to have them be blank. However, sometimes the reason why there's even parentheses there is that you can pass it additional information. sometimes some of these functions, these member functions, it actually requires you to tell it a little bit more detail about what you want it to do. For instance, Pokemon, when you say, let's go back to our example here. Remember I had member function to attack? One of these things is like usability is a member function of Pokemon, right? Pokemon can use an ability. But you would have to tell it what ability you want to use. So for instance, if there is a function on Pokemon called usability, for instance, if I had a Pikachu and did a dot usability like that, think about that. That actually is not enough information. You're not telling Pikachu which ability to use. So in that case, you actually will sometimes pass in what are called arguments in here. For instance, maybe I'd say use Thunderbolt as an argument. Or like quick attack. See how I have this string, which is quotes, as an argument? Sometimes you pass in more than one. Like let's say I use Thunderbolt. And I separate it. Let's say, I think in Pokemon, was it XY that you could have double two Pokemon fighting each other? I think you could target which one you want to use the ability on. So sometimes you want to tell it, oh, attack number 1, or attack the second guy, or the third guy, attack the fourth guy. Functions have a variable number of arguments, depending on the function. Some functions take 0. Some functions, like this one, would probably take 2, right? So going back to this right here, an example of a function that takes arguments is over here. So there's a function called find, finding chew. There's actually, you can call on the word, there's a function called find, and this takes what piece of a string you want to find. So I'm looking here, I want to find chew in that string. And it's going to print out where it found that piece. Oops, I missed a angle bit here. Let me zoom out a little bit so you guys can see the whole thing. This is me calling the find member function and passing one argument to it. See how it's not empty? I'm actually passing an argument. This is because if I left this blank, I'm telling it to find what? What am I telling it to find? It needs to find something specific, right? Shoot. So let's see where it finds that word. It'll tell me the position in this word of where it found chew. So 1. So remember, sorry, it starts at 0. So 0, 1, 2, 3, 4. It found it at the fourth character, or sorry, really the fifth character of this word. It can find other things too. Like we can change what it looks for. Maybe I want it to find IK. Where would you expect it to find that? What would this return? 1, right? So it's not searching for chew, ignore that. It's searching for IK, so it finds it right here. Okay? So it can actually find arguments. There's other things you can do too. Another member thing you can do is have it remove pieces of it. So you can have it say, hey, word1 dot erase. So erase takes 2 numbers. It takes where do you want to start erasing from and how many characters do you want to erase. So if I erase from 1 and erase 3 characters, okay, so I'm calling erase now, and the first argument here is going to be where do I want to start erasing from. The second number, separated by a comma, is how many characters do I want to erase. Okay? And then all I'm going to do is I'm going to print out the word again. So what would you expect here? It would remove 1, and then it would be P, and then chew. Oh, sorry. This is, here, let me do an ENDL. It's a little bit harder to see. So it's going to erase 3 characters starting from index 1. So watch what it turns this into. Pichu. So it has erased these 3. All right, it's turned that into that. This is a member function on a word you can call. You can erase a string, right? This thing also takes a variable number of arguments. This is a special case. I can actually just have it erase 1 character. Let me print this out again. So see how the first call to erase is erasing 1? This thing says erase 1 character, and this guy here is saying, hey, erase starting at 0. I'm going to start at 1 here to show you guys what it actually shows. When you leave off the argument on here, let me make this thing bigger. So see where I ended up here. I erased the stuff in the middle. Then I called erase with just 1 number in it. So that said, starting at this index at C, erase that, and then assume I want to erase the rest of it. Okay? You can also call erase, let me do this a little bit differently. You can also just call erase with no arguments at all, which means erase everything. Okay? These are 3 different ways to call the same member function. Not every member function that you run into is going to have this. In fact, this is a special case. Most of them are going to have one way you can call it and only one way. All right? This makes sense, like how erase can take 3 different ones. All right, so let me show you guys an example of how this works in like a game. I'm just going to make a fake object. Let's do tracer. So in this case here, don't worry about the struct thing. I'm just going to show you guys the usage of it here. This is how it could potentially. This is not actually how it works in Overwatch, but this is potentially how we would be using that kind of thing. My tracer. So on my tracer, this is an object that I've created called tracer. Notice it actually has highlighted blue, like this. See how like it actually is a different color? It looks like different from this. Anytime you see a color like this, it means that it's an object that someone else has actually made. Notice that strings also had that color. Right? And look how it looks different from like float. Anything that is blue is a built-in type. Anything that is a different color is actually an object, which means it's comprised of multiple types, multiple variables. Right? That's an easy way to distinguish how they're different. Okay, this is a lot of stuff we're going to go over in the object-oriented class. I just wanted to bring it up because when you call, like when we start getting into tic-tac-toe and we start doing SFML stuff, you're going to be dealing with objects that are already existing. Someone else has already written objects, just like how string is written already. And someone's written this code. The way string has been authored is that there's actually a programmer somewhere that actually wrote these erase functions. There's a program that wrote the implementation for these erase functions. It looks like this. Someone wrote this code. Thankfully, you don't have to worry about writing it yourself because someone already wrote it for you. However, keep in mind that this isn't just magic. Like, there's a programmer whose job is to implement more functions, more member functions to make this string class more useful. Okay? So when you're calling things like this, it's hidden from you, right? You don't have to know how erase works. If you had to do this, if you had to implement erase every time, if you had to write this yourself, I think it would be a lot more difficult for you to implement that. Like this is actually made up of a lot of different pieces. Like all of these are like very unique, specific behavior, right? All this code is someone writ, but you don't have to care about any of that because this is all hidden away in an object. Just like when you turn on your key in your car, you don't have to care about that at all. All right? So be thankful of that. Okay. Okay. An example of some other stuff we can do with strings. Let's talk about the next part of my lecture. And let me record the new one here. We're going to talk about something called arrays. So, and the homework is going to be based on that. We're going to make a very simple RPG game here. It's going to be kind of the start of an RPG game. It's going to be an inventory management simulator. For better or for worse, that's going to be the extent of our RPG game. Sound exciting? Okay. So what I'm going to show you guys is how you can deal with something that is a collection of variables. This is separate from objects. This is a completely different kind of idea. You oftentimes have a case where you need to store the same kind of information a lot, whether it's 10 or 100 or 1,000 pieces of information. If I asked you guys to give me 1,000 strings and store them so I could loop over them, how would you create 1,000 variables in C++? How would I make something that has 1,000 variables in C++? It's like 1,000 strings. I'd have word 1 here, right? And then I do word 2. If I create this, I'd have word 3, word 4, right? I would repeat this 1,000 times to get 1,000 different variables, to store 1,000 pieces of information, right? If I want to store 1,000 pieces of information, for example, for an inventory system, for an RPG, like I can store 1,000. I don't know how many Fallout can let you store, I guess based on how many you can hold, or like Diablo or WoW, based on how much bag space you have. But if I had to create one of these for every single inventory slot, that would be completely insane, because I can't have just 1,000 lines of code that I have to manage. I might mistype like half of them. Plus, I can't even loop over these things. I can't even write a loop to loop over these things. So one of the benefits is that C++ offers you the ability to create a lot of variable space very simply. If I want to create 1,000, let's say, numbers, instead of doing this and repeating this 1,000 times, there's a syntax in C++ that lets you declare an array of 1,000 types. In this case here, the syntax is actually based on the syntax for declaring a single variable. So if I delete this and I just want to have a variable called 1,000 numbers, right now what you do is you can set that equal to one single value, right? Instead, what we're going to do is we're going to add a little bit of syntax, and the way that you declare an array is always this way. Is you have the same exact thing. You declare your variable first. You declare your type of variable first, what kind of thing you want to store. Then you name the variable. Then next to it, inside a set of square brackets, you put how many of that variable you want. In this case, I'm going to do 1,000. Now I've just declared 1,000 integers that all have this name of variable. There's a few caveats to using an array. One of them is I have 1,000 of these, and they all have to be exactly the same type. Okay? I'm not mixing types here. I have 1,000 integers and only integers. I can't put floating point numbers in this. I can't put anything else in here. So in this case, I have 1,000. How do I actually get at them? You can imagine that this is actually this syntax here for square brackets. Whenever you see this, think about this is you dealing with arrays. Okay? So here's how arrays work. I'm going to open up my Excel, my Paint. Okay. You guys get to see me write this again. Imagine an array. This is how I see it in my head. Is I have a variable called numbers, and this thing has 1,000 elements in it. So in my head, what's actually happened is it's created a giant section with 1,000 slots for numbers in it. And they're all indexed. So if this is my, and this continues on over and over again, if this is my variable for arrays, I'm going to give each of these rows a number. It's going to be 0, 1, 2, 3, 4, 5, and so on. Each of these rows can store a number for me. All I have to do is know which of these rows I want to store it into, or which of these rows I want to pull it out of. Each of these rows is actually its own variable, which means that you can do all the things you do with normal variables, but you can access them via a row instead. The way that you do this, let's say I want to access the very first row of this array. I want to set that equal to 42. Normally when you have a variable, a single number, you assign it by doing this. If I just make this a normal variable, you assign it by doing that. You just say equals 42. But now that we have an array, you have to tell it which of those rows do you want to access. If I just do equals 42, it's saying, I don't know what this is. You're not telling me what row you want to index into, what array index you want me to put this number into. And the way you do that is, again, with square brackets. Inside square brackets next to that variable, you tell it what row you want to put it into. In this case here, I'm telling it to put it into row 0. Right? The nice part is I can also put a number into row 1 and row 2. See how it's very consistent? I'm using the same variable name, but I'm just changing the value inside it. The reason why this is so powerful is because the number inside here can also be a variable. So think about that. I can generate a random number that I use as my index, my row index. I can write a loop that uses that loop variable as an index. So let me show you guys an example of how this works. I'm going to make a variable called inventory. I'm going to put 5 items into it. Okay. I'm going to say inventory at 0 is equal to a sword. Okay. That's my inventory slot. At slot 0, it's going to be equal to a sword. I'm just creating a variable for that. Armor. And I'm going to do one that is shoe. Let's do 2 more. A horse in my inventory? How about let's do something like a castle? I don't know. If we're going crazy.
A miniature castle.
Count up how many of those inventory items I have. I have 5 inventory items. Look at my numbers though. Pay attention to my rows. Whenever you access arrays, the first element in that array, the first row is always 0. Okay. So now let's print out all these to the screen. Right, I'm going to show you the first naive way that we print out all 5. How do I print out the inventory item at 0? Inventory at 0. Right? Remember, anytime you want to use this variable, I can't just do this. I can't just print out inventory. That doesn't work. It doesn't know how to deal with inventory. You have to tell it what index you want to pull from. So if I want to print out 0, that's going to get me sword. Okay. How do I get it to print out horse? What do I put here?
Right.
Yeah, that'll print out the horse, right? Let's repeat this for all 5 inventory items. Okay, there are all my 5 inventory items. I'm literally just printing them all out. You guys can see sword, armor, shield, horse, castle, right? But this right here, don't do this. This is not the way you work with arrays. The whole reason why you do arrays is so that you can remove duplication and you can make your code easier to write. For instance, look at how much stuff is repeated over and over again. What is the same and what is different between all 5 lines of code? Look at all the things that are the same here. The cout, the inventory variable, and the endl, they're all identical. The only thing that's changing here is the index, right? So what construct do we have? What loop do we have that already does something like this, that counts from 0 and goes up? For loop, yeah. That uses plus plus, right? We have a for loop that counts up to a certain number. Well, why don't I just use a for loop to replace this whole thing with a single line? Watch what happens when I write a for loop instead. So if I take this whole thing and I watch, like, oh, there's a lot of duplication. A lot of stuff is the same. And the only thing that's changing is literally these numbers here. I'm going to write a for loop that counts from 0, counts up to 5, meaning it stops at 4. And watch, I'm going to do a cout. Okay, so I'm going to do inventory here. What can I put here to replace the 0? What can I put there? I? If I replace that 0 with an I, what actually happens? Think about what's happening to I during this loop. Remember, if I just printed out I, it would be 0, go up to 1, then 2, then 3, then 4. So if I just put I inside the square brackets here, like so, watch my result here. It's exactly the same, but it's one line of code, right? Make sense to everyone about how you access? This is me accessing an array element. Watch what happens when I don't do this, when I don't put in the I. That doesn't look like inventory to me. If you see something like this, you're missing the square brackets and the index of what you are accessing in the array. Okay? If you see that, that is a memory address of where the inventory is stored in your computer's RAM. Okay? Currently stored at 23F4A0. And that number is not going to be consistent either. It changes based on every time you run it. Because your computer pulls memory, like it's always swapping in and out memory based on what you have running, so that number's going to be different. Let's say you printed it out 5 times. So don't forget this, the brackets. You need to tell it which row do you want out of this array, okay? Any questions on that so far? Okay, let's expand this idea a little bit more. We have an array of 5 elements. What happens if I don't have enough room? What happens if I don't have enough room? I only have 2 inventory slots. You guys see what happened there? What am I doing here? I have 2. Imagine you're playing a game. You have only 2 inventory slots. You pick up 2 items, and then the game somehow lets you pick up a 3rd item, and a 4th, and a 5th. You're trying to put a shield, a horse, and a castle, and only have 2 inventory slots left. You're trying to shove these other elements in there. This is what's called an array out of bounds exception. This happens because when you declare an array, you have to tell how big you want that array to be, and it cannot change from this size. Which means I have to type a number here that's big enough to store everything that it possibly can. Well, I'll just make it like this. Well, that sucks. It says total size of the array must not exceed this many bytes. So there's a limit to this. And actually, it can't even handle this many. So here's the thing I'm going to say. You have to make this thing something reasonable, like something that's not like superhumanly large. Something that is like a reasonable number of inventory slots. There's another way to do arrays, which I'm probably not going to get to. I might get to this quarter, which allows you to have an array that you don't care how big it is. It'll grow as you need it. For now, this type of array, what we're doing in class, you have to tell it how big you need that array to be. pick a size that's reasonable. Like in this case, our game, let's just pick like 10 as the size. Let's say let's not go more than 10 items. Because otherwise, if you access an index, like if I did like 11 here, or 12, it'll crash. Okay? Your program will stop running and will crash. So this number here, 10, you can actually control it with a variable too. However, there's some restrictions here. You can't just put in any variable. For instance, watch what happens when I try to say, hey, array size. And I say, hey, I ask for the array size. I read in the array size. And I try to put array size here. You can't do that. You can't actually change the size of this. Remember, you have to define this up front. It's a contract you're making with the compiler saying, hey, I'm promising you that I know exactly how big this array is. If I change it so that array size is something that the user types in, you can't actually change it here.
Could potentially crash.
Well, that and the way these arrays work, when you build your program, it figures out how much memory it needs when you build it, not when you run it. Okay? Do you understand the difference there?
Yeah.
Like it has to know the size of this array at the time that I go to the build menu. And it can't know the size of the array because the size is based on what you type in here.
Okay.
So there is a way you can use a variable here, but that variable is, you have to promise that it never changes. And the way that you promise it never changes is you make a variable like this and you put the word const in front of it. And then once you do that, you can make this variable. However, it doesn't really buy you too much because this variable will always be 10 every time you run it. But that's the only case you can use a variable inside the array size like this. All right? Okay, questions on this? All right, let's go over the homework, and then we'll be done. Okay, so the homework is I'm going to give you guys, we're going to go over this inventory item. I'm giving you guys 5 inventory items the same time, every time. Like you're basically always getting a sword, armor, shield, horse, and castle. So the homework is going to be, where's my homework? I want you to change this program, and I'm going to put this program up on Zool so you guys can start with it. I want you to modify the inventory program so you're given 3 random inventory items instead of the same 3 every time. Right now I'm giving the same 5 every time. Literally you're given a sword, a horse, a shield, a castle. Pick a set of 10. What I want you to do is I want you to have a set of 10 inventory items. And then pick one of those and use that to assign it into the array. So I gave you guys some hints to follow. So what I want you to do is you're going to basically create a random number that rolls between 0 and 9, or 1 and 10, whichever one you want to use, using a switch statement or an if-else statement. You're going to pick which inventory item you want based on the random number that's chosen. So imagine I roll a 10-sided dice, and if I roll a 4, I'm going to give myself a shield. Okay? Once you've picked a random number, I want you to assign the inventory item to the array. So once it's finally done, you're going to print out all the inventory items that you got. The general idea is that here, this program is literally just printing out the same 5. Imagine, though, that you had potential for, like, let's just go through the list of potential inventory items that you can make. You could have, like, a sword, an axe, a fireball spell, I don't know, plate mail? You're going to write an if statement that says, hey, roll a random number, and depending on the random number, pick one of these. Okay? Okay. So what I want to do is every time I run the program, I want to see a different set of items that I'm printing in my inventory. Okay? There's one more thing I want to go over that I think will help you too. Right now, I'm always adding at a specific slot. There is a way you can make this thing more generic. For instance here, I have 5 items that I'm adding. What happens if I do this? If I delete 2 of these items? How many times am I looping over here? I'm looping 5 times, right? So what happens when I print those out?
2 blanks.
I have 2 blank spots here. What happened to this? So why do I have 2 blank spots? It's because I'm going over 5 items, even though I only have 3 total. Here's a way you can solve this. You can make a variable num items. It starts at 0. And watch what I do inside of here. I'm going to start this at 0. You guys remember when you do plus plus?
Yeah.
It takes the value and then adds 1 to it, right? So if I do this inside the array index, it's actually not only is it using num items as the row that I want, but also after it's done, it's adding 1 to it. And then here, I'm going to use that variable right here instead of 5. So watch how many times it loops over it now. Let me change this to be bigger so you guys can see. Look at there's no blank lines here. Let me go over that again. And watch what happens here. I have 3 items. I'm just going to demonstrate more of this. I'm going to have 2 more items in here. I haven't changed this at all. Look at the stuff inside the index. This is all exactly the same. It's all identical. But my result changes based on that. How does this work? Okay, let's walk through it. Num item starts at 0, right? Remember this thing, the way plus plus works? The first thing it does is it uses 0. It uses num items as value 0. So num items here is, imagine it just did this. What happens when I just do this without adding plus plus to it? This is 0, then it's 0, 0. It'll just be whatever 0, 0, 0, 0 is. Nothing. Why does it nothing? Well, num items here starts at 0 and is used here. This loops over no times. So this is me doing this. That's what that looks like. Okay, so that's why the plus plus is important, but what does it look like when you actually do plus plus here? Let's just do one line. What happens if I do num items and then do num items equals num items plus 1 right here? This starts at 0, then it goes to 1. Here's my sword. I start this at 0. If I just do a replacement here, I'm adding 1. I'm putting sword in my 0 inventory slot. And I need to keep track of how many items I have total. So I'm just going to add 1 to how many items I have total. If I just repeat this for each of the cases, now I have 2 items total because I added to it twice, right? Do this a 3rd time. Okay. I am indexing directly with the number, and then I'm adding 1 to this. The reason why you can just take this, though, is that the way the postfix, this increment operator works, is that first thing it does is it uses this variable, like so, and then it adds to it plus plus. So this right here is 0, and then it turns into 1 for the next line here. So then we add 1. the way this works is every time we add an element into the array, we're at the same time, we're also increasing how many we have. We're also saying that we have one more inventory item. So we're doing both right here at the same time. Okay? All right, so this will be the CPP file for the homework. I'm starting off with a sword, axe, and shield. What I want you guys to do is take this home. I'll put the homework up on Zool so you guys can all grab it. It's an SDVA103. I'll put this here. And then I'll put the homework document up on there too. So let me get rid of these. Someone has homework week 5 open. So take these two files home, homework week 7 CPP and the actual homework document, and that'll be what we turn in next week. All right? Okay, if you guys have any questions about this, email me during the week. This is a little bit of a trickier one, so it probably will take you a little bit longer to get it working. However, I highly encourage you guys to try the exercise that you've been doing in class, break down the problem into smaller pieces and try to do a little bit at a time. Okay? All right. That's it. Thanks, guys. I will see you guys all next week.